Welcome back to the second part of the explanation for how the Predator Active Camouflage system works. I'm slicedlime and I'm here to try to help you make some kind of sense of this monstrosity. Last time we looked at how the clocks are laid out for this thing, and a bit about how the scoreboards are used, and about which blocks we take into account for the different armor pieces. Today we're going to dive into the block detection and the way the whole calculation actually works. So that means we're going to get quite heavy on the computer sciencey bits, and I hope as many as possible of you can keep up. I'll try to illustrate it as best as I can. Alright, so the very first part of the process is something that is done here, and what we're trying to do is we're trying to detect the color of the blocks, right? So in this case we're executing for players who have a score of xn, that is 0 or less. So that means that if I look towards the negative x direction, this block is not here. So this is not a blocked position. And I'm just going to execute once. So if there's any player at all like that in the world, then we're going to execute this command, which is going to execute for a certain named armor stand that's standing out here in the wild somewhere. And what we're going to do is we're going to pulse stone and redstone blocks. So that is actually all of these things here. So if we take a look at these, you're going to get the actual detect command. So these are the things that actually run to sum up your total color score. So this one isn't going to match the one we're just looking at, but it doesn't matter. So if we have Predator boots and our score of XP is 0, so that means that we have the Predator boots, and the block that is one step away from us in the positive X direction is an air block. In that case, then we're going to detect the block that is positive in X direction, but also below us one. So we're going to look at the ground block, and then we're going to look for a stone block in this case, and its data value is 0, so that's a regular stone block. And if that is actually the case, that that's a stone block, then we're going to run this scoreboard players add at P. So the player that we're dealing with, the Predator boots color total, so the total value for the boots, and then we're going to add this mysterious number. This mysterious number is actually laid out in a very, very specific way in order to be able to add up all three color components and count the amount of hits we got at the same time. So in order to understand how that works, you're going to have to understand a bit of how computers work and how binary numbers work. But if I stand here, you'll see... Okay, hello ink sacks. If I stand here, you'll see that these numbers flash up, and that's what that's about. So, how do we arrive at this value then? Well, the average color value of stone, so if you take a stone texture and you just average it out, then you get a gray color that has 125, 125, 125 as the color values for red, green, and blue. Now those are 8-bit color values, so they span from 0 to 255. What we want is 5-bit color values to be able to fit this thing into one single scoreboard. That will give us a value between 0 and 31. And in that case, that means we have that this gray stone block has a value of 15, 15, 15. Now we have 5 bits per color, but that is 5 bits that's used up by a single color value, and what we're trying to do is add up several color values. So we're actually going to use 9 bits per color components, and then we're baking all of this together. So to find this number, we get 1, 0, 0, 0, 0, and then the number, which is 0, 1, 1, 1, 1, and then again 4 zeros for padding, and then 0, 1, 1, 1, 1, and then again 4 zeros, and then 0, 1, 1, 1, 1, and now what that is in actual decimal numbers is this whole number here, which appears to be 138,157,583. And the actual decimal value of this will never matter. All that matters is that we've used this scoreboard value, which is this 32-bit signed integer value, as data storage for essentially 4 pieces of information at once, and it's a count value for how many blocks that we have added, it's a red value, and it's a green value, and it's a blue value. So we're going to run that for, depending on which piece of armor it is, it's going to be between 8 and 10 blocks around you, and that's going to add up. And then of course, that was the value for stone, and then there's going to be a value for granite, and then there's going to be a value for, diorite, or whichever one that is, and then there's going to be a value for grass, and a value for planks, and a value for bedrock, and a value for flowing lava, and so on. So these blocks are going to contain all the different kinds of blocks that you can possibly have around you. Again, these are laid out the way they are to prevent that more than one of them gets filled in a chunk per update. Now, what happens when we add up these colors is that because of the way I allocated the bits in this binary number, we get the results separated from each other, and we have to actually separate them, and that's what this other piece of scoreboard operations do. So there's a bunch of math here, and what it does is it's going to set the count value. So this is the Predator chest count. So the PC is the Predator chest, and the C here is the count value. So we're trying to figure out how many blocks we hit. Because that we will need to divide the total by that amount to figure out what the average color is. Right now we have a summed up color. So we set it to the same, and this is going to be painful. And then we divide it by a certain constant, which is called shift 27. And if we look up that scoreboard object, set this by sidebar const. We see shift 27 is, well, a very large number. And what that is it's a value that is all zeros in binary, but it has a 1 bit in the 28th bit, so bit number 27. And what dividing by that value does is it shifts the entire binary number down by 27 spaces, which means that all we get left is the top 4 bits. Now the top 4 bits is a count value, and that can store up to 16 different values, so that contains our count on how many blocks we hit. If this seems like magic to you, I'm sorry, it's just a fairly in-depth knowledge of computer science and math. So the next thing we're going to do is we're going to copy this value, the count value, into the calc scoreboard, and the calc scoreboard is just a temporary space for calculations, and then once we've done that, we're going to multiply it again by this shift 27 constant. So what that's done is now we have only the count in the top 4 bits of this scoreboard value. And then the next thing we're going to do is we're going to copy the red value and start figuring out how much red did we get in our average value. So we're going to copy the total into that value. Whoops. And then we're going to subtract the calc value. So we'll remove the count value from that value. And then the next thing we're going to do is then we're going to divide that by shift 18, which works the same way. It shifts the color value 18 slots down. And then we're going to copy that because that's our red value. So that gives us a red value. And then we're going to keep doing this all the way down to green and then blue. And then here at the very end, then what we're going to do is we're going to divide our color values. So the green part of the Predator chest plate is going to be divided by the amount of blocks that we hit. And that gives us an average color. So I'm sorry again if that seems like magic. It's you have to understand that setup, you have to kind of be a programmer or know some programming constructs, and probably in some fairly low-level language. What is this? Sidebar PCR. So what that gives us is it gives us a value for between 0 and 31 for how much red there should be in our chest plate. And since I'm now standing with the only block it's detecting is this stone block behind me, so it's going to end up at 15 because 15 was the average color of the stone block, as we recall. But if I dive down here, it's going to get darker. It's going to be 10. We can back up towards these command blocks, see that the red component increases. So that's probably a pretty good place to end this episode. I hope that wasn't too bad of a mindfuck. Please do leave feedback in the comment section down below about what you thought about it, and if you want it, I can probably provide even more explanations down the line. Next time we're going to look at how we take these color values, the red, green, and blue, and use all of these blocks over here to actually turn them into armor pieces on your body. Until then, thank you very much for watching, and bye-bye.